These are examples for lesson 12.2 that are to help you learn the material for that. And in number 1, we're supposed to find the sine, cosine, and tangent of an acute angle theta whose terminal side passes through 2, 4. So on the coordinate plane, say x is 2 and y would be 4 for this point. So the point P is right about there. So the terminal side of the angle, if this angle initial side is here and it opens up, goes through that point. So what you're going to do is build a little triangle where the terminal side of the angle between the origin and that point is like the hypotenuse of a little right triangle. And then come straight down. And we know that we have a right triangle, and because this ordered pair is 2, 4, that this side here is 2 long and this side is 4 long. And then what we want to do is find the hypotenuse, because theta, the angle, is right in here, right? If this opened up like so, that's the angle. We don't know its measure, but we'll just call it theta. So I know that Pythagorean theorem can let me find the hypotenuse length here. So I've got one leg squared plus the other leg squared is c squared. So this is 4 plus 16, or 20, is c squared. So c is the positive square root of 20 because we're dealing with a distance. So 4 times 5, so this will be 2 root 5. So this radius I'm going to write in here is 2 root 5, or the hypotenuse. So anyway, to find the sine of this angle theta, it's going to be the y over the radius, y over r, or opposite over hypotenuse. So 4 over 2 root 5, so that's 2 over the square root of 5, and multiplying by 1 in the form of root 5 over root 5 to rationalize the denominator, I get 2 root 5 over 5. The cosine of that angle theta is the adjacent side over the hypotenuse, or this x value, x over r. So that's 2 over 2 root 5, which is 1 over the square root of 5, which when I rationalize it is root 5 over 5. And the tangent of that angle is just the opposite over the adjacent, or y over x. So to this angle it's 4 over 2, which is 2. Okay, so then we'll do something similar in number 2. We're supposed to find the value of all 6 trig functions if the terminal side passes through 5, 12. So I'm just going to make a little sketch. I'm going to go like about 5 over and about 12 up. And this will be the terminal side of some angle that opens up. It's an acute angle opening up in quadrant 1. So the point is 5, 12. So building my little right triangle, theta is here. So this is 5 and this is 12, and I'm not going to use the Pythagorean theorem here because you should remember from geometry at 5, 12, 13 Pythagorean triple. So we know that this hypotenuse must be 13. So I'm going to list the sine of theta and its reciprocal, which is the cosecant of theta. And I'll find the cosine and its reciprocal, which is the secant. And I'll find the tangent of the angle and its reciprocal, which is the cotangent. So the sine of this angle is the opposite over the hypotenuse, or 12 over 13. So its cosecant will be the reciprocal of this, or 13 over 12. The cosine of this angle is the adjacent over the hypotenuse, or 5 over 13. So the secant will be the reciprocal of that. And then the tangent of this angle will be this opposite side over the adjacent side, 12 over 5. And the cotangent will then be 5 over 12. So that's how to find trig functions given points in quadrant 1 that the terminal side of the angle passes through. Okay, Now, let's say instead of a diagram, we're just going to be given information about an angle theta, and its sine is 1 over 3, and we're supposed to find the cosine and tangent. So just sketch a little right triangle, and the sine input, we'll put theta here, and the sine is 1 over 3. Now this isn't really drawn to scale, but it's saying this side would be 1, and the hypotenuse would be 3. So I want to find this other leg length, so I'll use the Pythagorean theorem. So one side squared plus the other side squared equals hypotenuse squared. So x is the positive square root of 8, so that would be 2 times the square root of 2. So I'm supposed to find cosine and tangent. So the cosine of theta, if this is 2 root 2 on this side, the cosine of this angle would be the adjacent over hypotenuse, so it would be 2 root 2 over 3, and that doesn't simplify any further. And then the tangent of this angle would be, of angle theta, would be the opposite over adjacent, so 1 over 2 root 2, and I'm going to rationalize that by multiplying by 1 in the form of root 2 over root 2. So I'll have a root 2 in the numerator, 2 times 2, and a 4 here. And that would be the tangent. Okay, next we're going to talk about cofunction identities. And cofunctions are functions that, that have a relationship such that, well, I'll show you down here. If I have a right triangle and say I have an angle here, theta, side A, side B, and hypotenuse C, notice that whatever, we know this is a 90-degree angle, so these two are complementary and have to add to 90. So this angle here has to be 90 minus whatever this one is, so 90 minus theta. So notice that in this case, if I say that, let's say the sine of theta. So the sine of theta would be side B over side C. Well, notice that if I want to take the cosine of this angle, the cosine of the other angle, the complement to angle theta, is also adjacent over hypotenuse, so it's the same ratio, B over C. So the sine of theta is the same measure, the same ratio as the cosine of 90 minus theta. So this works for in both directions for sine and cosine. Those are cofunctions, and their reciprocals are also cofunctions of each other, cosecant and secant. And then tangent and cotangent are both reciprocals and cofunctions. So, number 4, let's say A, I want to find the sine of theta if the sine of some angle, theta, is equal to the cosine of 25 degrees, then this theta must be 90 minus 25 degrees. So this would be the sine of 65 degrees. Okay, if the cotangent of 70 degrees is equal to the tangent of theta, then theta must be 90 minus 70 degrees. So I could say the tangent of 20 degrees will be the same as the cotangent of 70 degrees. See how these add to 90 and these add to 90? Okay, so the cosecant of 15 degrees is going to be the same ratio as the secant of 90 minus 15 degrees. So this would be the secant of 75 degrees will be the cosecant of 15 degrees. So that's pretty easy to understand. That's cofunctions. And then the last thing we're going to do is look at some special right triangles that you learned about in geometry last year, 45, 45, 90, and 30, 60, 90 triangles. So let's fill out a little table, and you will find that this table is also on page 558 in your book. So first of all, the reciprocal functions we know for sine is cosecant. So the sine of theta, its reciprocal is cosecant. The reciprocal of the cosine function is secant, and the reciprocal of the tangent function is cotangent. Okay, so what we're looking at, oops, I went black. There. What we're looking at is if I take a little right triangle that's a 30, 60, 90, and I make the hypotenuse 2, then you learned in geometry last year, whatever the hypotenuse is in a 30, 60, 90, the short leg, which is opposite the 30-degree angle, is half that hypotenuse. So if this is 2, this is 1. And then the long leg, which is opposite the 60-degree angle, is this short leg times square root of 3. So that would be root 3 in this triangle. And then, for the 45, 45, 90, both legs have the same measure. So if those are both 1, then the hypotenuse would be the square root of 1 plus 1, so the square root of 2. Or it's just a leg times the square root of 2. So anyway, the sine of 0 degrees, and this is in your table, is 0. And the sine of a 30-degree angle, it would be opposite over hypotenuse, which is 1 over 2. The sine of a 45-degree angle would be 1 over root 2, which simplifies to root 2 over 2 when I rationalize the denominator. The sine of a 60-degree angle, opposite over hypotenuse, is root 3 over 2. And the sine of a 90-degree angle is 1. Now, these just reverse order when we look at the cosine function. The cosine of 0 degrees is 1, and the cosine of 90 degrees is 0. In here, in a 30-degree angle, where the sine is 1/2, the cosine is root 3 over 2. So looking at this 30-degree angle, its cosine would be adjacent over hypotenuse, or root 3 over 2. 45-degree angle, its cosine is root 2 over 2, and 60-degree angle, its cosine is 1/2. Now we learned about cofunctions, and see how the sine of a 30-degree angle is the same as a cosine of a 90 minus 30 or 60-degree angle, etc. And these two are the same, and those are both the same. So an easy way to find tangent, you can look at the table and see it here, or you can always divide sine by cosine. So sine of theta divided by cosine of theta will also get you tangent. So 0 divided by 1 is 0. 1 divided by 0 here is undefined. 1/2 divided by root 3 over 2 is 1 divided by root 3, and simplifies to root 3 over 3. 45-degree angle, sine divided by cosine is 1, and a 60-degree angle, root 3 over 2 divided by 1 over 2 is just root 3 over 1, which is root 3. So this is all on page 558 of your book for reference, but those are going to be good and important to memorize. So we want to use these to find out the measure of each side indicated. So in number 5, I have a 45-degree angle here. So this is a 45, 45, 90 right triangle, and one leg is 5, so the other leg is 5, and x, which is the hypotenuse, is going to be 5 times the square root of 2, or 5 root 2. Okay. In number 6, we have a 30-degree angle here, so this is 60 up at B. So this is a 30, 60, 90. So in a 30, 60, 90, the hypotenuse, the longest side, is twice the shortest leg, which is opposite the 30. So this x is going to be half of 13. So that's 13 halves. But just to finish it out, if I wanted to know what this side was here, it's going to be 13 halves times the square root of 3, or 13 root 3 over 3. Okay, and then the last one, this is a 60-degree angle down here, and so this would be a 30, and hypotenuse is 11. So if this is my 30-degree angle up here, my short leg is this one down at the bottom, and it's going to be half of 11, or 11 halves. And then x is going to be short leg times square root of 3. So 11 halves times the square root of 3 would look like so. So that's it, and I hope that helped a little.